on as part of the conference right now, and we appreciate your interest in this topic. So my name is Michael Jabley, and I'm the panel moderator for today's session. I'm joined today by Mr. Drosten Fisher from CAPE, Mr. Jason Opdyke from Amazon Web Services, and Mr. John Rogers, also from CAPE. And I'll give them an opportunity to introduce themselves as we get into this. From my background, I was active duty Navy for 34 years in submarines and have been peripatetic since retiring 7 years ago, done a variety of consulting services, 2 years full-time employment at Amazon Web Services, and additional support to the Navy as a special assistant for AUKUS. I'm back to consulting now, and in the interest of full disclosure, both CAPE and Amazon Web Services are my clients, so I provide support to both of them. What we're going to talk about today is secure communications over commercial cellular networks. And I'm going to start with Drosten Fisher, ask him to introduce himself, and then I'll give him his first question. Drosten?
Thanks, Michael. I'm Drosten. I run Navy business for CAPE. We worked with Indo-Pacific for about a year and a half. Before that, I was at Amazon with Michael and Jason. And then before that was at an AI startup called Data Robot. We worked at putting machine learning on submarines and doing sort of analysis of submarine data with machine learning, artificial intelligence. Thank you.
Okay, and I lied. I'm going to actually do two kind of scene setter things before I ask Drosten his first question. So the first one is Operation Spiderweb. So many of you have heard of this. This was the Ukrainian attack on Russian strategic bomber forces using unmanned aerial systems. And there's been a lot of open press reporting about this. I have no classified insight. I only know what I've read in the open press. But the interesting thing about this was that the command and control of the Ukrainian UASs appears to have been via commercial cellular networks. And you would think, okay, why would you use commercial cell networks? Well, it allowed the pilots of the UASs to exercise that command and control from a great distance, well beyond line of sight. President Zelensky conducted an award ceremony in which he recognized the pilots who had piloted the UASs, and every indication is that commercial cell networks were the mechanism by which this C2 is exercised. And so you would think, okay, well, isn't that a vulnerability? Isn't that a risk? Wouldn't commercial cell networks be rated in a conflict? And the answer is that, at least in the Ukrainian environment, it has been shown that both sides have prioritized maintaining cell networks for various reasons. So commercial cell networks present an interesting opportunity to act as a layer within a mesh network of communication. And that is recognized by multiple parties. The second thing that I'm using as a scene setter is a quote from yesterday's keynote where Admiral Kaler, Commander U.S. Pacific Fleet, said, "PAC Fleet is augmenting traditional military comms with scalable, agile options for contested, bandwidth-constrained environments. We continue to integrate these things like commercial SATCOM, 5 and 6G, and open radio access networks into our maritime architecture." So a pretty clear statement of interest from the commander of Pacific Fleet. So with that, I'll go to Drosten. Okay, so CAPE is a global telecommunications company. Anyone who wants to can go to www.cape.co and sign up for a service plan. Bring your own phone, $99 a month, and you can switch to them instead of your current cell phone carrier. But CAPE doesn't have any infrastructure. So how does that work, Drosten?
Thank you, Michael. So we are a commercial cell phone company. We're a startup, so we're venture capital backed by Andreessen Horowitz and some other investors. And most of our staff are not telco engineers. They were software engineers from Google and Palantir Androl, and elsewhere. And so we're really looking to revolutionize the cloud industry. And part of that is taking an old concept, which is an MVNO. I'm sure people see Ryan Reynolds for Mint Mobile, and they say, okay, I know cricket, this is something which is, kind of low cost, will get me connected, but maybe low value. And so we've come at this differently. We're trying to add the value of privacy and security, high privacy, high security. And so in our consumer business, we collect minimal information about our subscribers. Don't collect their name, don't collect credit card details, you pay them through Stripe, don't collect their address, no major name, their social security. Absolute minimum. We sometimes get the question, is this legal? Like, what if the FBI comes to you and says you want to surveil a user? And the law says in the US, you need to give authority the information you collect. It doesn't say you need to collect any particular information. It just says you need to give over what you have if requested. Okay, so the reason that we do that is because we respect privacy and security of the individual user and the right to hold them. And that also goes for our enterprise customers and our government customers. Typical MVNOs like Mint Mobile are just sort of marketing operations. They go over top of existing telco infrastructure and they run billing and advertising, and the underlying telco runs the network. We do things quite differently. So we're cloud-based. We run in Amazon. And so typical telcos have data centers, which are physical rooms full of servers. We're in the cloud, so we can scale very quickly based on demand. And we have our own 5G mobile core, which allows us to run the network. And so when we deploy overseas, we can offer different offerings to our customers. We recently set up an MVNO, a strategic MVNO in Mexico. And we did this in a way where we did a deal with a telco in Mexico, it's not yet public, it's going to come out soon, to use their cell towers. And then we set up secure VPN for each cell tower on mobile core, running in AWS, and then we can run that. And so if you think about cell companies, no cell tower network is ever at full capacity. Stands to reason, because otherwise cell calls would always drop and you could never get a signal. So all cell companies in the world have excess capacity in their network, and all of them are happy to sell or rent that capacity to other telcos. It's how roaming works. If I go to Japan, I'm going to get service there on NTT Docomo. I'm not a subscriber to NTT Docomo. There's just an arrangement with a telco in the US. So we've taken that a step further. We strike deals with telcos to roam onto their networks. And in certain specific locations where we think it's beneficial, we strike deals to run our network software on their cell phone. And so they will let us do that. They will come to an economic arrangement. And then we will effectively manage the cell towers. The network will now be an American network run by an American company in a foreign country. So the question is sort of why do they do that? It's economics. It's good economics for any telco if they have excess capacity in their network to rent it to another company.
It sounds like that could be a difficult process, negotiating with individual telcos around the world, especially when you start talking about placing your software on their towers. Is that a simple thing, or is that drawn out?
I think it depends on the quality of the telco. Dave Gibson in the back from IT&E is one of the partners we work with in Guam. They're a very high quality organization, and Dave is a very high quality individual. So when you're working with partners like that, super quick. In other places, it could be quite a bit slower. And it really depends on what I have found is the internal commercial logic of the specific company. So I have about zero ability from the outside. I've got a zero for core ability to predict which telco will be a good partner doing analytics. So you can be a management consultant, so I frame myself as very analytical, market studies, I gather all the data, and I've been wrong 100% of the time. And I was surprised because and the reason is, I think, I don't understand the internal commercial logic and go-to-market plan of a company. So I can look at the external dynamics that might make sense. And Telco A, given the external market factors, should be the one. But if Telco A has no interest in doing this, or has leadership that is not creative, or is very bureaucratic, it's not going to work, even though the outside logic makes sense. If Telco B, that seemed, by my analysis, to be unpromising, has creative leadership or entrepreneurial, and frankly, see an opportunity to take a share in the market. So, we've talked narrowly about the transaction where we rent spectrum and power usage. But more broadly, we've raised $91 million from our horizontal investors. We've spent that on developing highly innovative capabilities for privacy and security, and our local partners can bring that to their customers. So we actually bring innovation investment to the deal, which can be quite beneficial for local telco. And the telcos that are really keen to move forward with innovation, I think see an opportunity to not spend $90 million of their own money, their own kind of IRAD in developing innovation, but to leverage our investors' capital to get some synergy.
So you mentioned privacy and security, and that's one of the selling points of this capability that that Cape provides to the customer. When you talk about entering into contracts with foreign telecommunications companies, talk a bit about how you provide that privacy and security that's the selling point of this.
Yeah. So the first thing is sort of the commercial integrity of the company. We put in place an agreement. It's very clear on what the responsibilities are. We're very clear on what information can be disclosed, what information cannot be disclosed. We wouldn't enter into an agreement with a company that would disclose information about us striking, something we would not do. So that sort of process of reaching a legal agreement to share a network contains within its subclauses about privacy and things. And then once we're operating the network, we really have very little interaction with the underlying telco. So cell towers are relatively dumb things. They have some processing power to do, but really it's about sort of maximizing network throughput and signal beam strength. It's not about analyzing users and traffic patterns. The brains of a telco are in the mobile core, and because we're routing all the traffic directly from the tower to our core, we now are inside the control room. And the last thing we do, which we think is a real breakthrough for innovation in the sector, is we don't build data centers and build them with servers, which is more mobility. We run in the cloud. We inherit many of the security provisions from cloud providers, and in our assessment, cloud and cybersecurity leaps and bounds ahead of traditional helping.
With that, we'll go to Jason, who's been quietly sitting there. A lot like Amazon Web Services. You don't notice him, but he's supporting the panel. So Jason, let me ask you to introduce yourself real quickly, and then I'll give you your question.
Sure. Thanks, sir, for having AWS on the panel here, and we're happy to support Cape and its capability. I'm Jason Updike. I am a solution architect at Amazon Web Services. Actually, I have a team of 14 solution architects that cover the Air Force and the combatant commands. Our job is to help customers and partners and industry capability providers like Cape to advance their mission on our infrastructure. If you didn't know, AWS has the world's largest and most adopted cloud service infrastructure out there. 38 regions with more coming, 120 plus availability zones, 4 million unique customers. Those are businesses with physical addresses, 9 million kilometers of fiber optic cables. So a whole lot of infrastructure out there to help enable the cloud.
Okay, and so Drosten talked about this a little, but can you expand on what the AWS role is in this capability that Cape's offering? How does AWS support the command and control use case that we alluded to with Operation Spiderweb? If we were to run that on Cape capabilities.
Sure. Probably the most exciting part about being a solution architect at Amazon is seeing the capabilities that our customers and partners provide, and we power them. We are providing infrastructure. We provide infrastructure in all classification domains, if you will. You can think of the commercial side of the infrastructure. This use case in particular shows the value of commercial infrastructure and the benefits that someone like the DoD and many other users could reap. And we can talk more about that. We offer infrastructure for governments only, U.S. government only, with our GovClouds. Think of Impact Level 4, Impact Level 5 type information, as well as we have classified regions, secret, top secret, and support special access programs. So providing the infrastructure and 200 plus services to host and run your workloads, enable your developers to be innovative, and to really focus on the core business problem versus the blocking, tackling, or the what we like to say the undifferentiated heavy lifting of managing servers, infrastructure.
So you talked about securely leveraging commercial cloud infrastructure, and doing that to enhance resilience of communications in C2. What do you see as the key barriers and opportunities to expanding and furthering that leveraging of commercial cloud infrastructure?
Absolutely. So we have a lot of capability designed specifically to protect customer workloads from us, the provider, as well as protect workloads from tenants next to your space of the cloud. So first off, implementation of best practices regarding isolation technologies is critical. These are things that are already happening today. Critical functions of society are already implementing these protections. Things like strong identity and access management, strong network controls, data protection in transit and rest. Defense in depth, zero trust, you're all familiar with all of those things. The capabilities that Amazon provides enable you to do those easier than building your own solution or buying these services and products from many different. Now, the other part of this is we are very partner and vendor friendly and agnostic. Many of the startups and companies that we all are familiar with, think of Uber and your bank and DoorDash and your flights and all the things out there. So enabling those partners to deploy their innovation and give them capabilities that eases their burden as well. Again, focusing on their core mission is the key. Blockers for commercial. Well, I think there's this default place the government goes to where I need to have my own special part of the cloud that's accredited in XYZ compliance regime. All good value, and we're not saying that shouldn't be done. But when you think of things like the fastest innovation, the greatest amount of capacity, that lands in commercial first. So to have a fight and to have the most tools, to be ready for the fight and have the most tools available to you, probably should consider using commercial regions, not just government-only regions that are more limited, albeit accredited in different ways, more limited in capacity and availability. Again, with that whole worldwide infrastructure, you're getting the resilience and all that. The second main benefit is something like continuity of government. Should a conflict arise, I'm sure that government-only regions are higher on a list than all the commercial infrastructure, as proven by the Spiderweb example. The commercial cellular networks actually enable the capability. And then finally, there's a whole lot of use case around partner collaboration, the need of the United States to share information with our partner nation allies that may or may not be allowed into the U.S. government-only regions. So the U.S. meeting them in commercial regions is a great use case for MPE, secret releasable.
Okay, great. I'm going to get to you in a minute, John, but I want to go back to Drosten and ask another question on the security and privacy aspect of the CAPE offering. And this is really more towards privacy. One of the things that you post as a selling point on your offering is the ability to control identity management at the software, hardware, and network level. Can you talk about what that means and what that provides to the customer?
Definitely. I think I wanted to just piggyback of one last thing that Jason said about the benefits of commercial versus government infrastructure. ATOs, right? And so commercial infrastructure is not ATOs. ATO is cell phone on the face of it. Go to an ATO before I can make a call. And so same way AWS, we don't run in GovCloud. We run in commercial for that same reason, because we don't want to be slowed down delivering capability to our customers by having to go through the ATO process. So on the federal team, we might have quite some issues. In terms of privacy and security, there are some things that if you're in sort of telco world deeply, you understand how to maybe reach those things. And some of those things are more industry protocols than they are actual cyber vulnerabilities. And an example of that would be user IDs. And so there's typically a user ID you have for cell plans with IMSI. Typically, most carriers identify one user with one user. And then if you're hostile and like sort of surveil people, you can find people very easily by that number. People very rarely, general, change their cell provider, right? So we don't do that as a company. We don't have sort of internal processes that associate one IMSI with one person. We actually give our customers, some of our customers, the ability to rotate those things. This isn't the base $99 plan on the website. This is a more specialized plan called Obscura. There are variants, of course. There's a variant of this capability for executives, work with quite a lot of large companies and senior executives who are worried about having communications intercepted or surveilled with numbers overseas, and we work with a number of federal customers. So we give our customers the ability to rotate these identifiers, both at the individual level and of the phone. And so you can look like a bunch of different people, and your phone can look like a bunch of different phones. And that makes you, doesn't make you invisible, but you're sort of hiding in plain sight, like a needle in a stack of needles, because now there's not just one identifier associated with Drosten, there could be 1,000. And, you know, as an outsider, you really have no way of associating with
Okay. So the advantages of that are obvious, both from a identity management, security and privacy concern, force protection aspect, but also if you're using this cellular capability not just in a phone, but as a communications link to any platform, whether it be a small autonomous system or part of our largest platforms in the military. So with that, I'm going to go to John Rogers, ask you to quickly introduce yourself.
Sure. John Rogers. I recently left the Navy about a year ago. I was a cyber warfare engineer. Really, that means it was offensive cyber-oriented community, developing those tools for use cases. DDIL now. I also spent some time at the Defense Innovation Unit, particularly on the cyber and telecommunications portfolio, focused on Indo-PACOM, and now I'm with CAPE as a solutions architect, looking at the deployment side for Indo-PACOM once again, as well as other entities part of the DoD.
Okay, and so I understand that you've been spending a lot of time in the field doing testing on this capability, including with autonomous systems. Can you talk about what you have learned through that process?
Yeah, I think I'll start with particularly looking at cellular as a dual-use technology. Cellular sees billions of dollars of annual investment. It's ubiquitous, extremely high throughput. As kind of alluded to by Drosten, though, the trade-off is cellular was designed with trust in mind, the exact antithesis to zero trust. And prioritization was on the ability to connect and having continuous connectivity. So you get the benefit, though, of cellular is very easy to use, easy to connect to, and again, that high throughput. But the downside is you see the security vulnerabilities very apparently, especially in the last 2 years with the things like Salt Typhoon and these penetrations into all the major carriers, right? So from a dual use standpoint, especially coming from a DIU background, if you can leverage cellular in a way that's secure, you get access to something that is easy to use, device agnostic, and it's really just plug and play. So that's kind of where CAPE fits into this is if we can secure the use of this ubiquitous technology, you solve a lot of problems with one solution. And the best part is there's commercial infrastructure everywhere that's ready to be used, right? And so obviously everyone thinks with cellular, as mentioned, just cell phones. But again, cellular is device agnostic, right? So as long as you have a SIM card, to be a physical SIM card or an electronic SIM card, you put that on a device, it'll just connect as long as it has a cellular number. So something, and especially getting off of Operation Spiderweb, you have a lot of these drones are designed primarily with line of sight technology, right? So direct RF link, that's layer 2. There's no IP-based networking there, which gives you a lot of benefits. You have a great great throughput, extremely low latency. But the downside is it's line of sight, right? So a lot of things can interfere with that connection. Perhaps the next steps of that, if you want to keep that low latency in the 5 to 10 millisecond range, is fiber optic cables, right? That gets around a lot of the jamming problems, gets around some of the line of sight issues as well. Problem is you're limited by the extent of that fiber optic cable, right? So where cellular comes into this is, again, it's extremely high throughput, so it can support that ISR as well as the command and control, all that data being pushed across the network. And also, depending on what your core infrastructure is, and the beauty of AWS being able to deploy anywhere where there's a data center for AWS, you can have these core functions, so all these things that enable data throughput, close to where things may be controlled, right? And so, Cellular does introduce some additional latency, but the reality is it's still well within range of what is usable for an operator to drive unmanned systems. So we've been testing this with anything from UAS, so aerial vehicles, service vehicles, so in the littoral area, all these different places, being able to control unmanned systems in a way that's very similar to the experience of having a line of sight technology, that layer 2, or even fiber optic cables. But in this case, you can control something from a completely different location, right? The further away you are, obviously introduces some additional latency, but the reality is you can control something, sitting in your house in the United States, driving something, in this case, a good example is Mexico, as we took that network, there's a seamless connection between the user and that end system. You can do that from anywhere in the world. That's pretty powerful.
So what I'm hearing is that if you look at this capability as another another tool in a mesh network, if you were to try and build it as a government investment, you would have to be talking trillions of dollars to mimic or replicate or duplicate the commercial cellular infrastructure. But as long as you can get past the issue of using a commercial network, then that infrastructure already exists. And then your concerns with privacy, security, legality, access, that's really what the special sauce is here. That layering that on top of a commercial cell network provides you this resilient, elegant answer to the question of how can I get another option for communications in this mesh network?
Yeah, absolutely. I mean, I will say that there's obviously other options like Starlink and some certain other things, right? But the problem with those is a lot of times you have a fixed connection point that's not necessarily mobile, right? The beauty of cellular, and I will say actually it is a line of sight technology. I say line of sight as if it doesn't work, but the problem is obviously with other connection methods, you have to have that receiver and the emitter close to each other. It doesn't work with other emitters. But you cellular, and if you look at a coverage map with any carrier, right? They say they cover the entire United States or whatever country. That line of sight technology is already deployed in, right? Like you said, that would be an immense cost to set up those towers across the entire region to get that same connectivity that you would see from a commercial standpoint. But yeah, there are other alternatives like Starlink and other PLEO type options, but there's certain limitations in terms of mobility. That's the key piece that I think mobile answers, is that it's already has connector emitters and the ability to connect to these radio access networks anywhere. The ability for us to have a secure piece to that enables that mobility without the cost of the government. Right?
I want to go back to Jason. So we've been talking about autonomous platform use cases. So how is Amazon Web Services evolving the cloud infrastructure to support the unique requirements of military autonomous systems, especially in environments with intermittent connectivity or high latency?
Sure. So when I think about autonomous systems, I think about first having a resilient infrastructure with diversity in terms of connectivity as well as where your compute and storage is. So choice of resilient infrastructure and where you deploy is paramount. I think of operator access and providing tooling to enable secure comms, command and control into an environment. I think about real-time data and capturing multiple feeds, fusing them together very quickly. Think of the problem of monitoring the skies of North America. That's 700 plus radar feeds and ADS-B feeds that need to be fused very quickly with other data. Oftentimes move to higher classification regions through cross-domain solutions to get to a solution that had a requirement of object in sky creates dot on map in a classified region, in sub 2 seconds. So moving all of that data, fusing all of that data, and enabling decision advantage is paramount. And I think that's really it's data fusion, it's cross domain, it's connectivity. You all are providing that connectivity into the cloud. We are transport agnostic. When you want to come to the cloud, we'll let you come in numerous ways. Whether you're terrestrial or cellular, or we offer even some type 1 protected direct connections into our classified regions. That's the other thing. Is everything's using commercial in the end. It's whether or not you have encryption devices on those links or not. There could be space as well.
That is, and it raises a question for Drosten here. Can you talk about layering encryption on top of this, and then what other security partners does CAPE operate with to enhance the privacy and security?
Yeah, device level, we've got some partners like Rafi coming, others, for example, partners. We use commercial encryption technology. I think we set out for identifiers. We don't put any information out of the structure telcos. A lot of information transferred into telco network encrypted. A lot of information in telco networks is unencrypted. We encrypt everything, all kinds of identifiers using commercial encryption technology. And then we set up our own networks in countries. We have VPNs between cell towers and point cloud. On top of that, again, back to my point about not wanting to go across the ATO boundary, we haven't really got into government level encryption. We provide unclassified transport there and backhaul, and we let government customers do what they would. We'd be something comparable to fiber or PBS, and we're not sort of looking to go into that classified domain and trying to go across the boundary. A couple of things we like about that approach is it's very flexible. So commercial clouds got a bigger footprint than the government cloud. And then I think the other thing that we like about working with global companies like Amazon is that when you get into their system, there are ways that routing that traffic in a way that's highly secure, so you're not actually a little bit more focus needed on kind of network diagram and structure when you get that in place. We find it very, very beneficial. So I think, look, there's really a defensive depth. No system is unbreakable, no code is unbreakable, these things don't exist. But if you layer on multiple protocols together, increase the difficulty for people that want to access your information and get more.
Okay, so I don't want to oversell cellular communication capability. I live in Northern Virginia, which is the region with the highest concentration of data centers on the face of the planet, and probably one of the highest concentrations of cell phone towers. But in my neighborhood, there's an intersection that I drive through that if I'm on a phone call, it drops every single time. So I'll go back to John and say, okay, so in your testing in the field with autonomous systems, what did you learn about the reliability of cellular connections, and why is it that if I get half a mile away from that one cell phone tower, I lose connectivity, but you're able to demonstrate hopefully a better track record?
Yes, absolutely. Actually, I grew up in the Bay Area. I don't know if the Bay Area, but the Bay Area was also notorious for terrible cellular coverage. It's supposed to be the tech capital of the world, right? The reality is that's just the byproduct of time back to line of sight technology. As if there is essentially RF blockers in terms of construction materials or anything along those lines, it becomes essentially a dead zone for connectivity. So you kind of get around that by raising the height of the emitters. So having an antenna higher, in this case being a tower, right? Increasing the elevation gets around some of those blockers or RF dead zones. But the reality is it's a byproduct of some of the things that block the emissions and the locations of towers, right? So if you have a tower that's a relatively low elevation, there's probably going to be hills and valleys and areas where the line of sight technologies can't reach. Sometimes it can be reached through like bouncing, right? Some materials can result in a bounce and fill that dead zone through other mechanisms. But in the end, it's a line of sight technology. And looking at the use case of unmanned systems, actually the byproduct of an aerial system is you go above some of these blockers, which actually helps with connectivity, right? The consistency and the availability of the line of sight technology. You hit the UAS when it flies, actually helps with that, right? A lot of those dead zones are going to be closer to the ground, vice obviously up in the air. And similarly for USVs, so unmanned service vehicles, not a lot of blockers in the ocean, right? Barring an aircraft carrier driving by, that will kill your signal probably. But beyond that, there's actually great connectivity in the ocean as a result, right? Even though cellular providers orient their towers such that they do not emit over the ocean, the reality is there's a lot of incidental coverage. And this is actually a great positive point for cellular in that even though people don't want emissions to reach certain areas, it incidentally does because it actually does propagate extremely well from a line of sight perspective. So it is obviously a mixed bag. Unfortunately, the intersection would probably need a tower to be deployed there specifically to fix the gap. But for the most part, especially from an unmanned systems standpoint, relatively strong coverage. And I guess that does tie into another concept, which is private cellular networks, right? So if you want to fill a specific gap, you could always deploy a private cellular network, which is either government-owned or commercially owned or anywhere in between to fill certain gaps for certain users that need to be filled. And that is actually something that we can do is single SIM roaming, right? So the ability to have a single SIM, no user interaction, walk between private and public, right? So even where there is gaps, can be filled with several different options. And of course, having one cell tower to fix a dead zone, and then using commercial cellular as the rest, a lot cheaper than having your own network deployed in the entirety of the region, right? So there's a few different options.
So let me follow up on that real quick, and then we'll go to you, Rustin. So I mentioned that my career was in submarines, and that's the classic issue of, for a radio antenna, your periscope depth, minimizing the height of eye to maintain your stealth, while balancing that against connectivity. And so yeah, you say there's not a lot of blockers in the ocean, but when you talk about an antenna that you want just above that air-water interface, then you start bringing in things like wave height, and, that causes clutter and can impact that. So when you were talking about expanding that reach and walking between commercial networks, the ability to, for instance, create a bubble network as a relay, have you operated with that in the exercises and testing that you've been doing to solve some of those problems?
Yeah, and that could take many different forms, right? Because essentially a mobile core, at its essence, depending on the number of users, is a pretty lightweight piece of thing, right? You can put it ostensibly on a Raspberry Pi. Obviously, not many users can connect to it, but it is feasible, right? So the footprint of those bubbles and whether or not you want a core service deployed alongside it, there's a lot of options and variants in terms of the footprint. But the reality is, in the end, as I was saying before, cellular is device agnostic, right? So you can have a bubble that is deployed out maybe in the middle of the ocean or barely in range of a cellular tower on land. Use that as its backhaul and emit a new signal in that bubble that creates essentially a backhaul that way, right? In which case, it's a smaller bubble connected to a bigger bubble, and that could be real. There's any number of options there, but in the end, because cellular is an agnostic to the device, you can create those bubbles in which you want.
Yeah, I wanted to go back to the unmanned systems point. So in the example of insufficient coverage, a lot of unmanned systems navigate with waypoint software, and so they'll be going from point A to B to C. If signal breaks in between, they've kind of got their waypoint, so you don't need continuous connectivity to navigate. You could mix up waypoint navigation with operator control. And so if the operator loses connection, therefore control, the unmanned system keeps on the waypoint through its next waypoint and its next waypoint until it can pick up effectively. I think one thing we've seen as a strength of cellular networks is that they reattach very quickly, a few seconds. Other types of technology, they go down, they can take a long time, like satellite technology goes down and take minutes to reattach, whereas we found with cellular technology, it reattaches quickly. And then the other thing I think we're investing in is, we're fundamentally a software company operating in the telco space. We're not a telco company, so we operate a network. Physical transport layer for our network happens to be cellular, but it doesn't need to be. because we have IP-based transport running on top of our app. So we can layer network to network. We can strike deals with multiple telcos, and we can even strike deals with non-telcos. We've experienced Mike Hodge in the back from Link. We've done some great work partnering with them. They are a satellite company that puts cell towers in space. And so now, if you have a break in coverage from the cellular network, so you're in the ocean and you're far out and you can't get it, you get satellite coverage and the cell tower in space, and you get back to the cellular network. So another way to mitigate kind of coverage lapses is to layer network connectivity on top of each other. You could use multiple cellular providers to increase coverage. You could use satellites to give you a cell tower in space. You can use Wi-Fi, if you're in an environment. And if you put together a networks approach, that mitigates coverage gaps in significant places. So if you get some satellites above your neighborhood in Northern Virginia, and you'll be okay.
I have found, not that I would ever exceed the speed limit, but if I happen to hit a green light and I'm going through the intersection, sometimes it'll hop and stay connected. Oh, okay, we're going to shift to Q&A at this point, and if you have a question, please use the mic here in the middle, and be happy to entertain it.
Test. This is for Jason, AWS guy. I know the conventional wisdom was like for businesses, you get your data in the cloud, you're good. But with the recent outage with AWS, can you speak about what Amazon is doing to assure consumers that their data is safe, they're going to be able to access their data? I know it made a lot more people more skittish about using the cloud. I know my father in particular, he said, put your data in the cloud. He said, I don't want it in the cloud. I want it on my computer. So if you can just speak to that.
Sure. Yeah. I think, we have a saying in Amazon that says there's no compression algorithm for experience. So there are certain things that happen when you grow and scale and advance that are unpredictable. I would say I would urge everyone in this scenario that's kind of in a trust scenario to be transparent, to be communicative, and to really explain what happened in scenarios that cause pain, like you mentioning. So what we do is we have a process inside of Amazon that's called a correction of error. We look deeply into scenarios like what happened last week. You can go read our initial reports. It's very technical and very detailed, actually, what happened. It's a race condition between a DNS update and our DynamoDB, which is our NoSQL services. Race condition is an unforeseen situation where software, many different microservices are out of sync with each other. But you can go read on our website about that. That COE process, correction of error process I talked about, actually takes many months for us to do. And effectively, we are out here attempting to earn your trust every day with your workloads, servicing your customers. And the only way that I believe a company in that situation can operate, especially when it's unforeseen circumstances, is to be fully transparent, demonstrate that we're committed to maintaining that trust, and sharing all of our lessons learned and showing it happening. There's a Microsoft one happening today. I don't know. So it happens to everybody, and it's part of growing and maturing and maintaining trust. Thanks for the question.
And on that point, Jason, there's another side to that, right? So as a telco, we think very deeply about, should we be cloud-based? Should we have our own servers? It's a choice we've made, but we expect that and we visit it, particularly when outages happen and our telcos don't get servers because the cloud's out. But recently in Korea, South Korean government decided to be completely localized. They localized government cloud. They put all of their government data on a nationalized Korean cloud. Then they had a fire in their server area and they lost the entire data of the South Korean government, their backup, right? So as we think about cloud versus on-prem, we've got to consider both, there's some accident, you lose it, and it fails to go out and you can't use this out. And I think, I want to give credit to Amazon for getting that back up quickly and transparent. So it did go down, it came back. and it wasn't as impactful as having a server room that went down, like everything's gone.
Yeah, I will echo that and say that for me, the biggest thing is uh, analysis and learning from the event, and then transparency with the customer. Um, quick side note, I won't name the hotel I'm staying in, but yesterday morning, there was no hot water. And I called the front desk and I said, "What's going on?" They said, "We don't have any hot water." I knew that. And they couldn't tell me anything more. And it was out for about 18 hours. And so this morning when I checked out, I said, "I'd really like to know what happened." And the manager said, "Well, I can have the engineering team come talk to you." So I spent about 15 minutes talking to the engineer. And what had happened was there was a car accident in Waikiki, and it hit a power bunker and disrupted the feeder that provides all of the western end of Waikiki electrical power. This is about 10:30 at night on Monday night. And I said, "Okay, I get that, but how long was the power out for?" About a minute. I said, "Okay, then why was the hot water out for 18 hours?" I said, "Yeah, that was us." He said, there's a super fancy thermostat, and all the guys had to do is reset it, and they were looking at circulating pump, power supply, and heater and pressure. And I said, "Okay, well, I appreciate you leveling with me." He said, we're learning from this. We're implementing resiliency. We have a backup, uninterruptible power supply to the thermostat, and we're training all our guys." I said, you know, "That's great. I mean, that sounds like what we used to do in the submarine force in terms of incidents and analysis and training and corrective action." But I really appreciated the fact that the engineering guy was willing to talk to me and admit that they had made a mistake, and as a result, I'm not going to write an angry letter to the but that introspection, analysis, correction, and transparency, I think is key. Other questions?
I think first I'll say I've learned to embrace the cold shower. It's very refreshing some days. Um, Help me understand. So when we're talking about like a drone and its use of a mobile network, I think of my phone, and if I've got T-Mobile and I've got bad coverage, I'm like, oh, this would be great if I could just cut over to AT&T if I'm in Texas and it's got better coverage. How does a drone leverage, or how could a drone leverage multiple carriers to bridge those coverage gaps?
So we carried it. No. So in the US, carrier. The only way to do that was get a roaming route from foreign telcos, Polish, put it on a drone. If you can rotate an access, so we have a capability. If the unmanned compute power, then basically the apps are in the no networks are available. This one on one here, no one network. So in theory, you've got the right to use between them, carriers. Unmanned vehicles, we're developing the capability. You guys may or may not know Sim has so you can write app with Sim link. Probably be harder to get on one. But it it's how long is very long. Yeah. Yeah. Other questions?
Looking at Operation Spiderweb, it seems like the United States is very vulnerable to the same attack. It seems to me it doesn't take much to set a dumpster outside Pearl Harbor and do the same thing to us. Can you talk like how vulnerable America is? Is America ready for this the new drone fight, like what we're seeing in Ukraine?
What I will say is that you quickly get into a much higher classification level when you start talking about those things. But I will say that counter unmanned aerial systems is a key priority of the Department of War, and the ability to um, to detect and defeat those systems it has to have a whole of government approach, because we're talking about things like legal authorities, rules of engagement, um, tactics, techniques, and procedures, and technology, and how all those things need to act in concert with each other to give the forces responsible for protecting critical infrastructure and military bases, personnel, platforms, etc., giving those forces the ability to guard against that kind of attack. But it's one of those things where you go much beyond that, and you're quickly at a much higher classification level. So I'll just leave it by saying it is published that it's one of the highest priorities of the department right now.
I think I will. If we look at Europe, what we're seeing with Russian we're seeing some tensions like that. Is Russians are flying drones like Belgium, and protocols drones on they can shoot it down, can not shoot it down. What if it causes civilian damage, lands on a school? I don't think people report these things. So even the technology we do in Belgium, they're going to start living theaters of like shoot down Russian drones. Rules of engagement are clear if they're not clear that this like that Russian fighter jet flew with Belgian airspace. At a certain point, it's like pretty clear rules of engagement. Like we told you to turn back, didn't turn back. Now it's like what accident. If a drone flying like around King Airport or something like that, it's not as clear that that's eligible. I think it's still good to actually follow the so I think that all these additions to technology, like surveillance, fiction, that's like how we can do this, and we can bring drones and it's possible to fly like a fighter jet. Maybe the last thing is most civilian drones around, so you actually don't know parameters.
Well, actually, on a little bit of congratulations to cellular components specifically. My understanding they use prepaid SIMs, mobile SIMs, and that actually uses the announcement point is great of risk in that it's budget and so how you need to purchase something companies like that. That's the industry you right. So that were the case, and the local carrier that's ostensibly very close to our equipment, they can twin those systems, right? If they did deactivate the nose of the cars or deactivate the operation, look at that in the water before you start. With also, I think the cellular phone with back on operation, that's a security risk in terms of attack. That's really the use.
Okay, in our final 5 minutes, I'll ask each of the panelists if they have any final thoughts, and I'll kind of frame it for you as you look at the future of this capability. What do you see as the biggest barrier to making it as valuable as possible? Start with John.
Yeah, I think it just ties back to the original design of cellular, which was trust, right? Implicit trust between carriers globally. And I think that as technology moves forward, things are being embraced notably, right? As forward because of 5G, 5G is security mechanisms that are default to technology, right? The reality is the first priority is always going to be connectivity to use connectivity. There's always going to be the risk of it's more prudent to left on your users than not. And that will always have to solve risk to it, like kids being solved constantly on those. So moving forward, it's really a question of securing the technology from a very level standpoint, and then minimizing how much data is available to this very those things are those, frankly, especially if you're reselling information, financially, they do come out. So there's some perverse incentives there, not for security. But at least from the technical standpoint, it's 5G, from 6G for 5G network, security is at least from the technical standpoint.
Jason?
I would say I've been doing the IT thing, 15 years at Microsoft, 6 at Amazon now. Amazon and really the idea of cloud really only started in 2006. We're at 20 years. I think we're still very early days in terms of cloud. Just in my own experience, most conversations in the beginning of that time frame were never will I ever, and that pendulum has started to swing. I'm seeing more and more customers moving to the cloud because they want to, have to, and need to. And again, they want to focus on their core problem. They want to let their smart people solve their hard problems rather than mowing the lawns of IT. I think that, like our CEO said, it was very early days in terms of cloud adoption. I think it's only going to be getting better and more ubiquitous. And I do think there's a lot of benefit in commercial cloud with this new
Rustin?
In terms of widespread adoption of a security and privacy focused cellular offering, I think awareness is probably the biggest barrier. The barriers we're finding are not technical. We're finding applying a software approach to the industry allows us to give pretty significant jumps forward in capability. But we're finding awareness is being really affecting the rate of adoption of that technology. So on the consumer side, awareness of the risks to consumer data, I think is listed. Awareness of how much the telco typically monetizes what's contained in patient data, preferencing, and cyber browsing. And so I think as people become more aware of that and concerned about it, frankly, people don't care that it's so right. If people become more aware of the amount to which what they're going to be monetized by the telco industry, then they look to alternatives. I think in our enterprise customers, there's some pretty significant vulnerabilities in the cellular networks that enterprise customers will not accept in IT networks. They're just not aware, I think, typically the enterprise security teams of those risks in cellular networks. So again, as that awareness increases, then we're expecting adoption of this technology pretty fast in that space. And then it's always in the federal space. The federal customers are very well aware of the vulnerability of networks. Maybe less aware of some of the things you can do to mitigate those vulnerabilities. Right? So I think in general, across the Department of War and the military, folks have always written off cellular networks overseas as people use signal on the side that they shouldn't. But actually, they have not eventually realized that the cellular network could be open for broad usage. And I think once those security protocols and approaches that we're putting in place become more widely known, extensively tested, that awareness spreads, we spend adoption, so so really in all three areas, it's not a technical barrier, it's really an awareness of the capability.
I tell you, I couldn't agree more. I got my first cell phone in 1992 when I was engineer on the USS Ohio, and it was a government cell phone, so about this big. My first personal cell phone was a couple of years later, but I've been with the same I've been almost with the same cell phone company for 34 years. The only reason it changed was because I was with Sprint, and they were bought by T-Mobile. So I know that my fingerprints are all over information everywhere, but I didn't realize it really until I was introduced to this capability and started learning about it, exactly how much we sacrifice in terms of privacy as companies pursue monetizing our information. So it's been an eye-opener. So I thank the panelists for their time. I thank the attendees for their time, and AFCEA for organizing this conference. And with that, the panel's concluded. Thank you very much.